So the last thing in 2.1, the last information we're going to get from this graph is a couple different function values. I'll actually maybe sort of write these over here so we can still see everything. And so I'm just going to list a handful of sort of semi-random values, and then we'll use the graph to find them. So let's say f of negative 2. Let's do f of 0. Let's do f of positive 1. Let's do f of 3. Let's do f of 5. So that's 5 points, right? If we had the formula for this, that would be like a few minutes worth of arithmetic like we were doing on the board the other day. But from the graph, if all we're trying to do is just like find these values, it's much faster. If we have a visual of the graph, all we're going to do is sort of pull this information directly from it, right? So remember that all of these values, right, in the parentheses are x values, and so the f of x values are the y values that come out of it. So what we're going to do is just go from left to right. So we're going to start at x is negative 2, right? So x is negative 2 is here, but the question is, where is that coordinate on the graph? Where is that coordinate on our curve? And so the answer is, well, that's sort of the beginning of our curve, right? Is here at negative 2. And so what we're finding when we're finding these f of x values are essentially we're finding the height values. These are supposed to be the y coordinates that come paired with the particular x values. So in this case, I kind of have it labeled already, right? But this is, so at negative 2, if we sort of traced it over, our y value would be positive 1. I kind of have it labeled here in the point. So f of negative 2, x is negative 2. What's the y value that goes with it on the graph? So the height there, right, the y value is positive 1. So without having a formula, we're essentially just filling that in. We're just getting that sort of pair, right? So it's the x value in the parentheses, and then the y value is our output value, what we're sort of getting from it. If we run through these, then the rest of them, so if x is 0, x equals 0 sends us right here in the center. On the graph, that's up at our y-intercept, right? So the y-coordinate here is 3. So our f of 0 value is going to be positive 3 because it syncs up with that height value, the output value. Positive 1, f of positive 1, so x is 1. So x is 1 is here, right? But again, we trace it, so up to our curve is here. The height, right? If we sort of trace this over, right, the height value here is 4. I've kind of got this point labeled already. So our f of 1 is 4. Did I accidentally label all of these? I did. That was not on purpose. The last two, right? So f of 3, x is 3. So we're kind of going 1, 2, 3. Trace it up to the curve. And then the height that goes with it, if we trace it back, was positive 2. So f of 3 is 2. Last but not least, x equals 5, right? 1, 2, 3, 4, 5. Up to the curve, our curve is here. This is once we flattened out, and so we're just sort of sitting at y value 2. So this is going to be 2. We can kind of assume any like f of x value where an x is bigger than 5, 5 and beyond, is just also going to be 2. This is sort of what we would call a constant function from that point on. If I asked for a little bit of a weird one, what if I asked for something like negative 4? So what's happening there, right, is I'm actually trying to find a function value where if I go 1, 2, 3, 4 backwards, I just don't have a curve here, right? I mean, the graph ends at x equals negative 2. So negative 4 is outside of our domain. There just isn't a value there. So what that means for us here is we would say this is sort of like D&E, does not exist. Or we could say, right, undefined. So it could be that we just don't have a coordinate there, in which case we're just going to label it does not exist or undefined.